Hey guys, we're going to talk about tides here. I'm going to try to keep this as simple and straightforward as possible because it can be, um, it's really more involved than we need to get into. Um, so I'll try to keep it short. If you look over here, I have a couple of pictures that I've pulled out. Usually we kind of go into detail about the moon's phases, but basically this kind of lays out the moon's phases for you, and the ones that are important to us. If you were standing on the Earth and the Earth is rotating, right, and then the moon is also making its way around, basically we'll see different phases of the moon. The important ones are going to be the new moon, and then first quarter full moon, and then third quarter. And the reason those are going to be important we'll get to in a minute, but basically it's the sun, moon, and earth alignment that's going to change the effect of tides. So first thing we need to kind of digest is this real quick, just because a lot of people don't realize what the tide is. It's a lot of people understand that it's created by the moon, but really it's actually created by the sun and moon. Anytime you have fluids on a celestial body, I guess, it will interact with other objects of mass, and there is a tidal force. So this is basically the tidal generating force, and it run through calculations and whatnot. Notice that the sun is huge in terms of mass, so really it would have a really great effect on the Earth's tides. However, notice how far it is from the Earth. So it lessens the impact of its tides. So the moon is really, really small compared to the sun, but it's really, really close compared to the sun. So it actually has a greater effect on Earth's tides than the sun does. But the sun still has a tidal force, or creates a tidal force. It is 46% that of the moon, which means that it is roughly the moon is roughly 2 times that of the sun. So 2 times tidal force than the sun. So the moon is more important in terms of understanding how the tides change relatively quickly. But before we get there, let's kind of go back up here, and let's look at, a tidal force is basically it's the sun pulling on the earth, and then water being compressible, or it can expand, right? So it's pulling on the water. So basically what happens is, and really it's centrifugal force and stuff going on, but we'll just leave it at this. But basically what happens is the sun creates a bulge of water that's moving towards it, right? And that's going to be the tide, okay? Then on the back side, it's kind of like if you were ever, swinging a bucket of water, right? You have to pull with a force that's equal and greater to that, or opposite that force of the whatever's in the bucket, in order to keep whatever's in the bucket as you swing it from sloshing back out. So this is like the water in the bucket swinging around the sun, and so this is in the bucket, and then this is the force that's required to keep it in the bucket, if you kind of look at it that way. But bottom line is that the sun creates a force here, or a tidal force, and that tidal force, remember, is basically 46% of the moons, or 50% of the moons. So the tidal force of the sun equals basically half of the moons, right? Then if we factor in the moon, so I'm gonna look at to do this. Let's go. All right, let's do. All right. So if we factor in the moon's tide, if we look at the moon, say at this location right here, the moon will have a much more greater effect. Much more greater. Great English, Trope. right? But basically it's going to pull water towards it just like the sun did, right? And this tidal force is going to be 2 times that of the sun, right? So if we make sure that we have that tidal force. Now, what happens is this. If we are on, say we're right here on the coast of East Coast, right? The Earth is going to be rotating, right, around within that bulge. So essentially what happens is, as you rotate around in a 24-hour period, you are going to rotate through this bulge, out of that bulge, back through this bulge, out of that bulge, and then your 24-hour day is up, right? So in 24 hours, you will experience, so 24 hours, you will experience roughly 2 tides, right? Some people say 4 tides. We'll say 2 high tides, right? 2 high tides. Now, again, this is the crayon drawing, so don't get too crazy with it. But let's look at what happens with the sun's interaction, because remember, this drawing isn't quite complete. You also have the sun's tide, which will look like this. So on this day, you'll actually, as the Earth rotates around through that bulge, right, you'll go through a high tide, then you go through kind of a low tide, then you go through a higher low tide, then a high tide, and then a higher low tide, right? So basically this situation becomes important because when you have a quarter moon, right, which is the half moon, but it's the quarter phase, that is going to create what are called neap tides. And those neap tides will have higher than normal low tides, and then they will have lower than normal high tides. So it essentially brings the difference between the 2 tides down a little bit, okay? So if I erase all of that mess and get back to the drawing, let's look at what happens on the other end. So if I were, oh, it takes forever. If I were looking at the new moon or the full moon, it's basically going to be the same effect. But if I were looking at the new moon or the full moon, I'll go back to green here. The moon's tide again is going to be, this is obviously over exaggerated, but is going to be a high tide there. And then the sun's tide is also going to be lined up within that tide. So this will actually amplify the tide. So you basically get like essentially 1.5 times the tide, right? And so again, if you were on the Earth here, right, and you were rotating through tides, you would rotate through a really low tide, and then a really high tide, and then a really low tide, and then a really high tide. This situation, when you are in the full moon, is going to be, so we'll say full moon equals higher high tides and lower low tides. And that is called spring tides. It has nothing to do with like a spring, meaning the season. So these don't happen in seasons. They happen at the full moon and the new moon. So new moon and full moon will be the same effect. What it is it's a spring. So the tides spring up higher and they compress like a spring lower than normal, right? So here's what you need to know about tides, and this is where we're basically going to go with this. We're going to keep it as simple as possible. So moon gravitational force is 2 times the sun's, right? Then at quarter moons, we get neap tides, which are higher than normal low tides and lower than normal high tides. And then the third thing we need to know is that at full and new moons, we get what are called spring tides, which is higher than normal high tides and then lower than normal low tides. So basically the difference between the tides is greater. If you know that, we should be good on tides. Remember, it's the Earth rotating. I'll add that to this. Earth rotates through the tides. Because remember, it takes 28 days for the moon to complete its journey all the way around the Earth, right? And so in that 24 or 28 days, the Earth is rotating every 24 hours through that bulge. So essentially, as the moon is moving around, right, when it moves to here, right, the tidal effect will be a little bit different. The bigger tide will be here, the sun's tide will be here, right? So then as it moves a little bit more, we're still rotating through that. It basically rotates that bulge a little bit more, and we rotate through that. So the fifth thing then would be that roughly 2 high tides and 2 low tides in 24-hour period. It's actually a little bit more than a 24-hour period because the moon has moved by the time the Earth gets back around to that position, so you have to add a few more hours, but it's roughly a 24-hour period. So if you know these 5 things, then you essentially know enough about tides to kind of be good for our purposes. Now, what can tides do? Organisms can, a lot of times, will have breeding habits that correspond to tides. For instance, turtles will lay their eggs in a certain time, where then the hope is that they would hatch during a spring tide event where the water is closer to where they laid those eggs, which then helps them to, hopefully, the babies to make it to the water faster and survive a little bit quicker or better. So there's things that can happen in terms of mating events. Animal behavior is kind of loosely based around tides, so it's relatively important. But really, the biggest thing is how do tides affect a region, right? And so if I also kind of come back up here, note that this number 5, this 2 high tides, 2 low tides in a 24-hour period is not always the case. Again, that is trying to be as simple as possible, but really there's a lot of places, if you've ever been to the Gulf of Mexico, for instance, there's really only 1 high tide and 1 low tide during the day. And the reason for that is, let me get some stuff out of the way here. Excuse me. So the reason for that, if you look at the Gulf of Mexico, it is kind of that, you got Florida, and it comes around, and you got like the Yucatan Peninsula or whatever, right? And then you got all these little Cuba, Hispaniola islands, right? So as you rotate through that bulge of water, right? So as that bulge of water comes in to the Gulf, the last tide is trying to get out, right? So usually what happens is, as that high tide comes in, as it tries to go out, the next tide is coming in, which essentially keeps it there, right? So the tide stays longer than it normally would, and then after that, high tide comes out, it has a chance for the water to leave, which then creates a low tide. So usually you only get, in these areas, you get 1 high tide, 1 low tide on any given day. So any land interactions that aren't just typical land interactions, you will have differences in tides. There's some places where you'll have like a high tide, right, and then you'll have a low tide, and then you'll have a higher high tide, and then you'll have a low tide in a 24-hour period. So that's weird too. So there's 3 types of tidal patterns that we probably need to be familiar with. I'm going to write them here, and then what you'll want to do is go find like a picture of these just to make them a little bit better than what I've got here. So the 3 types are going to be wrong thing. Are going to be semi-diurnal. Then there is a mixed I think it's mixed diurnal. And then there's just diurnal. Now, okay, I lied. I went and got them for you because actually I kind of forgot what they were myself, if I'm being honest. So these are the tide cycles. So notice diurnal is where you get 1 high tide and 1 low tide in a 24-hour period. That's kind of what I was talking about there in the Gulf of Mexico. Semi-diurnal is our normal situation where we get 2 high tides, 2 low tides. They're pretty similar to each other. And then this mixed semi-diurnal is what I kind of alluded to earlier when I drew kind of the difference in tides there. So you have a low tide, then you have a high tide, then you have a higher than low tide, and then a higher than high tide. And this is not like this is in a 24-hour period. So this is not like talking about spring tides versus neap tides. So basically what would happen in a spring tide versus neap tide situation, if you were in the spring tide, so if you were full moon or new moon, then this would all just be amplified. So if I grab my brush, if I were in a spring tide, this lower than low, or this low tide would be lower, this next high tide would be higher, this tide would be lower, and then this tide would be higher. And that would be a spring tide in whatever situation, based on geography, would happen here. If you were in a spring tide here, it would just be that this high tide would be higher and this low tide would be lower. If you were in a spring tide here, this would be lower, higher, right? So those are all things that could happen. If we were looking at neap tides, you would have a higher or a lower high tide, so it would be here, down a little bit lower, and then you'd have a higher low tide, right? So it'd be a little bit higher. Here it would be a little bit lower, a little bit lower, a little bit lower, or sorry, higher, really. So that would be in a neap tide situation. Same thing here. If you were in a neap tide situation, it'd be a little bit higher low tide, a little bit lower high tide, a little bit lower, a little bit higher low tide, and then a little bit lower high tide. That's higher low tide. I don't know. You get the idea. So those are the tidal patterns, and again, those are based on areas of the globe. Now, what also happens is kind of cool. Up near the poles of the Earth. So if this is the United States and blah blah blah, South America, right? Somewhere up here near the poles, the effect of the tides is much greater. So there's areas that will experience 40 feet differences in tides. If you look at the Bay of Fundy, that's a place that there's some videos that show. I think that's how it's spelled, Fundy. If you look at that, there's some really extreme tides in those locations. If you ever watch the show Alaska, The Last Frontier, or any of those Alaska shows, that they talk a lot about tides there too. They get tides basically every 8 hours that will change within 40 feet of each other. So those are all places that have really extreme tides. So those are tides. I think I'm going to kill that video there, and then we'll move on to a quick one, hopefully, about weight.